Good morning everyone and welcome to General Physics 2. We will learning a new topic this morning and this is all about capacitors. And I am Jemima T. Guladupe, your pre-service teacher for today's video. But before that, here are the learning outcomes that we will guide us as we go on through our lessons.
First, describe capacitors. Second, differentiate capacitor and battery using a Venn diagram. Third, explain how capacitor works. And lastly, recognize the significant application of capacitors on devices.
Last meeting, we already discussed the electric potential is in a uniform field. Today, we will discuss another topic about electricity, which is the basic component of electronics and used in various applications, which is the capacitor. But let's know first, what is the origin of the capacitor and how it was invented?
Capacitor is originally known as condenser. It was discovered by the Prussian scientist Ewald Georg von Kleist in 1745 and independently by the Dutch physicist Peter van Maschenbroek at about the same time, while in the process of investigating electrostatic phenomena.
It is considered to be the very first capacitor was called the Leyden jar. It was a glass jar wrapped inside and out by a thin metal foil which is a fundamental electric circuit for storing electricity. This was the old photo of a Leyden jar. So capacitor is a two-terminal electric device that possesses the ability to store energy in the form of electric charge. As you can see from the illustration, it has a two-terminal and inside container it has two foil, which is the cathode foil and the anode foil, and between is the separator called dielectric. And dielectric is a thin insulating material between two parallel conducting plates. Before I proceed class, I have a question first. Is battery and capacitor are the same? What do you think class? Both the capacitor and battery perform the same function of storing and releasing an energy. However, there are essential differences between capacitor and battery in the way they function. So, in what way they are different? In capacitor, charging and discharging rates are faster than the battery, while in battery, charging and discharging rates are comparatively slower. Second, capacitor potential energy is stored in the electric field, while in battery, the potential energy is stored in the form of chemical energy, which is later converted to electric energy. And lastly, capacitor is composed of thin sheet metals held close together or separated by an insulator, while battery is composed of metals and chemicals like zinc, potassium, and manganese. On how capacitor works, let's watch a video on how capacitor function or acts with the battery and the electric device.
A capacitor is similar to a battery in that both store electrical energy, but a capacitor is a much simpler device that can't produce new electrons. It only stores them. However, capacitors can do things a battery can't, as we will show here. For the purposes of this animation, we'll focus on different parts of the current propagating through the wires at different times. When we close the switch, electricity immediately runs throughout the circuit. Although the convention is to think of electrical current as moving from positive to negative, electrons actually move from negative to positive, as we represent here with yellow particles. As you can see, the battery is not much good at powering this motor to lift this weight, because it discharges gradually, much more slowly than would a capacitor with the same charge. Here we'll learn why a capacitor is much better suited to such a task than a battery. Like a battery, a capacitor has two terminals, positive and negative. Inside the capacitor, the terminals connect to two metal plates separated by an insulator that keeps the plates from touching each other and allows them to hold opposite charges, maintaining an electric field. Capacitors can be useful for storing and quickly discharging electricity, so you can power, for example, an electric motor as we'll show here. First, we need to charge the capacitor. By closing the switch, we create a circuit that includes both the capacitor and the battery. Electrons flow from the battery to the capacitor, where they are stored. Here, a yellow glow represents the increasing charge held by the plate. For every electron gained by that negative plate, an electron is lost by the positive plate, maintaining the capacitor in equilibrium. Here, the red glow represents the positive charge held by the plate that increases with each parting electron. The capacitor continues to charge until it attains the voltage of the battery charging it. Now that the capacitor is fully charged, let's put all that stored energy to use. By connecting it to a new circuit, we can power a small motor. This electrical current powers the pulley to lift the weight until the charge dissipates. The electrons on the capacitor's negative terminal are drawn to its positive terminal. They rush along the path that leads there, straight through the motor. Let's watch this again. Even though the battery and the capacitor attempted this task with the same amount of charge, only the capacitor successfully powers the motor lifting the weight because it discharges much more quickly. This feature makes capacitors useful for powering things that need a quick surge of energy, such as flash bulbs and cameras, and starter motors and audio amplifiers in your car.
After watching the video, you'll see that the capacitor is much better suited to perform rather than the battery because it can charge and discharge quickly as the electron of the current also flow quickly in motor device. If the capacitor is charged, then its charges will be neutralized. And if the capacitor is already consumed, then its charges will be dissipated. Let's proceed on the different structures of capacitors. So first is parallel plate capacitor. It has two parallel charging plates are separated by dielectric that contains charges. The capacitance is directly proportional to the area of the plates as well as the distance between these plates. Example is RESS or Rechargeable Energy Storage System and batteries. Second is cylindrical capacitor. It has an inner and outer cylindrical structures. The dielectric is placed between these two charged cylinders and the capacitance is varies directly with its length. Example of this structure is electrical power cable or wires. And lastly, the spherical capacitor. It has an inner spherical structure wherein the charged bodies of capacitor and outer spherical that covers the internal sphere. Dielectric is placed between them and capacitance varies directly with its overall radius. Example of this is the Van de Graaff generator. After we know the different structures of capacitor, let's proceed to the different types of capacitor used in a wide range of industries and in everyday life. First is electrolytic capacitor. It is used when the large capacitor values are required. The dielectric plate is a thin layer of oxide. It is developed electrochemically in the production with thickness of the film. Majority of these capacitors are polarized, which means the sign is indicated. They are generally used in DC or direct current power supply because of its large capacitance and for coupling or decoupling applications. Second is mica capacitor. This capacitor is a group of natural minerals. Mica is used as dielectric. They are low-loss capacitor which allows them to be used at high frequencies, and their values does not change much over time. The third is paper capacitor. The construction of this capacitor is between the two tin foil sheets and they are separated from the paper or oil paper and thin wax. It is used in various high voltage and high current applications. The fourth one is film capacitor, a non-polar capacitor that uses a thin plastic film as the dielectric. This capacitor is stability, low inductance, and low cost. It is used in the aerospace and military technology. The types of film capacitors are polyester film, metallized film, propylene film, PTE film, and polystyrene film. They have the same function, only differ in dielectric as material. The fifth one is non-polarized capacitor. These are capacitors with neither positive nor negative polarity. They are typically found in coupling, decoupling, compensation, feedback, and oscillation circuits. Examples are silver mica, paper, and ceramic capacitors. And the last one is ceramic capacitor. This capacitor uses ceramic material as dielectric. The ceramics are one of the first materials used in production of capacitor as an insulator. That's the end of our discussion, class. It seems that you've understood every part of our discussion. To measure your learnings in our discussion, answer this activity in a 1/2 sheet of paper, where in a Venn diagram, compare and contrast the capacitor and the battery. And second, answer how capacitor works. So that's all for today, class, and I hope you've learned something today. God bless everyone, and thank you for listening.